Hello. I've been taught a good mathematician challenges everything they are told. Today I'm going to challenge the concept of zero. I hope to prove what you've been taught is incorrect. We're going to begin by playing a game which I call shoot. And in this game, whenever we fall on a space that has a shoot on it, we follow that shoot down to a particular number. So let's begin. I'm going to roll my dice, or die, since I only have one of them. And let's say I get a 5 on my first go. So 1, 2, 3, 4, 5. I'm at space 5. Now I roll it again, and this time I get a 6. 1, 2, 3, 4, 5, 6. We might note that 5 plus 6 is 11. This is how we define addition. Now I'm going to roll a 4. 1, 2, 3, 4. I land at the 15. And when I fall down on the 15, I get to a 3. So 11 plus 4 is 3. Because wherever I land at the end of my roll, that is what my count is. Now you may look at this as strange. I've gone from 11 to 15, but my answer is 3, according to this game that I play. Well, it may not be as strange as you think. Over here, I have a clock. And if I played the same game I did before, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. And 4 plus 11 is 3. Nothing is strange about that. So this little game of shoot that I play has somewhat the same rules as 12 up until the number 18. At that point in time, there are no shoots. However, when I play with one die, I can't get beyond 6. So now, let's take a look at the number line and think about how we create our numbers. Okay. To create 2, we take 2 1s. So 1 plus 1 is 2. To create 3, we take 3 1s. 1, 2, 3. They're 1. However, if we took those 2 1s and replace it by the 2, we get 1 plus 2. And if we wanted to create 4, it would be 4 1s. But if we took 3 of those and replace it by a 3, we would have 4 plus 4 is equal to 1 plus 3. So what we begin to observe is that our numbers are created adding 1 to the number before it. Well, what's the number before 1? I've just slipped in a few numbers before 1. I've slipped in a 0 and something I call A and B. And what I begin to notice is that if I use the rule that I developed before, that when 1 is added to a number, it gives me the next number. Well, the number before 1 on the number line is 0. So 1 plus 0 should give me 1. Well, let's take that a little bit further. 2 is equal to 1 plus 1. But let's replace these one of those 1s, by 0 plus 1. So I now have 0 plus 1 plus 1. But I know 1 plus 1 is equal to 2. So replacing those 2 1s by 2, I showed that 0 is, when added to 2, gives me 2. And similarly, I've shown the same thing with 3. So now I begin to question this comment that when 0 is added to a number, we get the same number because 0 is nothing. Not true, as far as I'm concerned. It's because 0 is the number before 1 that it has what we call the identity property. When I ask people what is a negative number, they tell me its location. They say it's the numbers left to 0. I don't like that definition. Let's take a look at how we build our numbers. If we call these numbers here A and B, we will see that when we add 1 to A, we'll get 0. And when we add 1 to B, we'll get A, because we create our numbers by adding 1 to the previous number. Now, if I subtract 1, I just move it over to the other side, and I see that A is equal to 0 minus 1. Now, I'm going to just call it minus 1. I'm just going to forget about the 0. And so now we see that it's notation that is the way we name our numbers, and that because of that notation, we get A is minus 1. Okay, now we take and add 1 to B plus 1. We get B plus 1 is equal to A plus 1. 1 plus 1 is 2. So B plus 2 is equal to A plus 1, which was 0. And now, if I move the 2 over to the other side as I did with the 1, I get that B is equal to 0 minus 2. And using that same notation, B would be minus 2. So now we see how we may have discovered negative numbers. At this point, it is convenient for us to show what the definition of a negative number is. We'll notice that before we had A plus 1 is equal to 0, and we showed that A was minus 1. So if we substitute minus 1 for A, we get minus 1 plus 1 is equal to 0. And similarly, if we do the same thing with B, we get minus 2 plus 2 is equal to 0. So we can see that when a negative number is added to its inverse, we get the identity element. Now, you'll notice on that number line that there is no minus 0. Well, let's see how we might discover where minus 0 is. Because when I once asked a first grader to write the negative numbers, he wrote them as 3, 2, 1, 0, minus 0, which seemed to be a reasonable way of doing it if you follow the pattern. But we know that 0 plus 1 is equal to 1. And if we add negative 1 to both sides, we find that we get 0 plus 0 is equal to 0. And if I use my rule for subtraction and move the 0 to the other side, I get 0 is equal to minus 0. And by my notation, that's the same as minus 0. So we find what we've been taught, that minus 0 is in the same place on the number line as is 0. So we had seen before that when we added negative 1 to 1, we got 0. And when we added negative 2 to 2, we got 0. So what I'm going to do is now define a negative number in a different way. A negative number, when added to its inverse, gives us the identity element for the environment which we're in. So on a line, 0 is the identity element. But on the clock, as we saw before, 12 is the identity element. And 12 is definitely not 0, confirming some comments I made earlier. So minus 1 plus 1 on the clock should be equal to 12. And minus 2 plus 2 on the clock should also be 12. If I now subtract 1, which basically means move it over to the other side, I get minus 1 is equal to 12 minus 1, which is equal to 11. And I get minus 2 is equal to 10. But look what happens. When I add 4 to 11, as I saw in my shoots game, I got 3. When I subtract 1 from 4, or add minus 1 to it, I also get 3. Similarly with the 2. So, this makes us look at numbers in a very different way. So, in summary, what we showed is the identity element for addition is the number before 1. On the number line, it's 0. On the clock, it's 12. A negative number added to its inverse is equal to the identity element. That's the way we define negative numbers. And we gave you the examples before that on the number line, the identity element is 0, and on the clock is 12. Well, there's something to think about. Ask your parents, ask your teacher. See if they can refute what I have said. If they can't, you've learned something new. Thank you very much.